Power series. We start with a few examples of power series. So power series is an infinite series which involves variables. For example, n x to n, which we can write as x plus 2x squared plus 3x cubed plus and so on. Second example, for example, n from 1 to infinity, x to n over n. So x over 1 plus x squared over 2 plus x cubed over 3 plus and so on. Third example, n from 0 to infinity, x minus 2 to n over n factorial. So we can write this one as n factorial is 0, 0 power is 1, so 1 plus x minus 2 over 1 factorial plus x minus 2 squared over 2 factorial plus and so on. So in general, power series is going to look like a n x to n to infinity, and n starts somewhere, where power series is going to look like a n x minus some a to n and start at n to infinity. We're going to call this power series centered at x equals to a, and this one centered with center at x equals to 0. Because we are working with the series, we're going to be concerned about two questions. The first one, which will be discussed today, is where series, whenever series converges or diverges. So in this case, for power series, we'll be concerned about questions for which axis series is convergent and for which it's divergent. Example, if we look at the series n from 1 to infinity, n x to n, and we have a question for which axis of this power series is convergent. We are going to apply ratio test. So we got rho equals limit as n approaching infinity, n plus 1 times x to n plus 1 over n x to n, absolute value of that expression, limit as n approaching infinity, n plus 1 over n, using rule of thumb, that is n over n, and x to n plus 1 over xn is just x. So at the end we get absolute value of x. So rho equals to absolute value of x. So recall the ratio test. If rho is less than 1, it's convergent. So in our case, rho equals absolute value of x less than 1 convergent. Rho which equals absolute value of x bigger than 1 is divergent, and rho which equals absolute value of x equals to 1, that's for question mark. So what we've got is the following situation. When absolute value of x is between -1 and 1, between these 2 points, it's going to be convergent. When absolute value of x bigger than 1 is going to be divergent. And we have 2 question marks when absolute value of x equals to 1. So to finish our problem for which x of power series is convergent. All that is left is figure out what is happening when x equals to -1 and 1. So let's finish that up. So if x equals to -1, we have series n equals to 1 to infinity and -1 to n. And if we do divergence test, take limit of n times -1 to n, then approaching infinity, that is not equal to 0, because you see n is approaching infinity, so n is going to be infinity, and -1 to n, what it does, it just moves that big number between positive and negative. If now we check the over point, x equals to 1, we got a series of n times 1 to n, and from 1 to infinity, which becomes series of n. And again we do divergence test, we take limit then approaching infinity and over term, so we're going to get infinity not equals to 0. So in both cases x equals -1, the series is divergent. No, the limit is not equal to 0, so that is also divergent. So our answer to this question is going to be something like this. Series x to n and from 1 to infinity is convergent when x is strictly between -1 and 1. We want to state the following theorem. If we have power series x minus a to n multiplied by some coefficient a to n and starts, say, from 1 to infinity, then we have three possibilities. Either the power series convergent at x equals to a and divergent at x not equal to a. So that's a first possibility. Second, there exists number r such that if x minus a absolute value of less than r, then corresponding power series is convergent, and if absolute value of x minus a bigger than r, then corresponding series is divergent. In the third case, power series is convergent for all x. So the theorem says that we have only three possibilities. The power series always convergent, the power series divergent almost always except for a case when x equals to a, and that's kind of obvious because we have zeros, or we have some number r so that it's convergent when the distance is from the center is less than r and divergent when the distance bigger than r. So I'll illustrate the second case. So second case says if we have a center a, x equals to a, then we have x equals to a plus r and x equals to a minus r. So we have distance r and distance r. So on that interval the series is going to be convergent, and outside is going to be divergent. So on that interval, centered at the center where we have power series is going to be convergent, and outside it will be divergent, and R is going to be called the radius of convergence. That's for number 2. And if we refer to number 1 and 3, for number 1 we will say radius equals to 0, and for number 3 we'll say radius of convergence equals to infinity. Next problem, we want to find the interval and the radius of convergence of a series x to n over n and from 1 to infinity. I will do a ratio test. We're going to get rho equals limit as n approaching infinity x to n plus 1 over n plus 1 over x to n over n. Take absolute value of that expression. So we're going to get limit as n approaching infinity x to n plus 1 over n plus 1. We're going to take the reciprocal of that expression, n over x to n equals, doing rule of thumb for n and n plus 1, you're going to get 1, rule of thumb, and x to n plus 1 over x to n is x. And don't forget absolute value, so we get, so rho equals to absolute value of x. Now if rho is less than 1, it's going to be convergent. So absolute value of x less than 1 is convergent, because that is our rho. So what we've got is x equals to -1 and 1. That's when the absolute value of x equals to 1. So between these two is going to be convergent, outside it's going to be divergent, and we have question marks for our boundary points. So from here, just looking at that one, you see that center is 0, so from 0 to 1 and -1 to 0, our radius of convergence is 1. Now to find the interval of convergence, we need to figure out what is happening at x equals -1 and at x equals 1. So we need to figure out what is happening at the endpoints of the interval. So x equals -1 and x equals to 1. X equals to -1, substitute -1 into the power series, so we're going to get -1 to n over n, and from 1 to infinity. You recognize that there is alternating harmonic series. Convergent. If you like, you can say by AST. If you plug in 1 into a power series, we're going to get n from 1 to infinity, 1 to n over n, which becomes 1 over n, and from 1 to infinity, you recognize harmonic series. P equals to 1, P equals to 1, it's divergent. So the interval of convergence is going to be at x equals -1 is going to be convergent, so we want to include -1, but we don't want to include x equals to 1, so we put strictly less than 1. because at x equals -1 it's convergent, and at x equals 1 it's divergent. So for interval of convergence we want to say we want to include -1, all the points between, but exclude 1. In this example, we're asked to find the radius and the interval of convergence of a series x minus 3 to n over 2 to n. To do that, I will do root test. And if I do root test, I will take nth root of absolute value of x minus 3 to n over 2 to n. So we're going to get limit then approaching infinity, x minus 3 over 2. So we get x minus 3 over 2, absolute value of it. So we get rho equals absolute value of x minus 3 over 2. Now we want to figure out where rho bigger than 1 and where rho less than 1. So we want to figure out when absolute value of x minus 3 over 2, which is rho less than 1. So multiply both sides by 2. And absolute value of x minus 3 equals to 2. 5 minus 3 is 2. And 1 minus 3 is 2. So between these 2 points, absolute value of x minus 3 is going to be less than 2, so it's going to be convergent, because rho equals to that. Outside is going to be divergent. And question marks right on the edge when x equals to 1 and x equals to 5. Right? So from here we can see immediately that the radius of convergence rho equals to 2. We see the center is 3. Center is 3 because we have x minus 3. So from 3 to 5 is 2, from 1 to 3 is 2. So radius of convergence is 2. All that is figure out to find the interval of convergence, what is happening at end points, what is happening when x equals to 1, and what is happening when x equals to 5. So let's figure it out. If we substitute 1 for x, we're going to get 1 minus 3 to n. So 1 minus 3 to n over 2 to n, sum, and from 1 to infinity. We're going to simplify that expression, and from 1 to infinity, we're going to get negative 2 to n over 2 to n. We're going to reduce that expression. Negative 2 to n is negative 1 to n, 2 to n over 2 to n. 2 to n cancels out, so we have negative 1 to n, and from 1 to infinity. And this series is going to be divergent by dt, because if you look at the limit of negative 1 to n and approaching infinity, that's not equal to 0. So when x equals to 1, we got divergent. So we don't want to include x equals to 1 into our convergence interval. X equals to 5, substitute 5 for x. So we're going to get n from 1 to infinity, 5 minus 3 to n over 2 to n. So we're going to get 2 to n over 2 to n, reduces, so we get series of 1. And if we take limit of 1, it definitely not equals 0. So divergent by divergent test. Now we're ready to finish and write down the convergence interval. So the convergence interval, we don't want to include 1 because it's going to be divergent at 1. We don't want to include 5 because at 5 it's divergent.